Well, hello there, everyone. We are going to be taking a look at the calculator questions on the Calculus B final, starting with number 1. Suppose the rate of water is approximated by qt equals this function 0.01 multiplied by the quantity of 950 plus 25x minus x squared. The question is, find the average rate of water usage over the 24-hour period. So just to remind us, the average of anything in calculus is 1 over b minus a multiplied by the integral from a to b of f of x. This will give me the average of f on the interval from a to b. Well, we want to find the average water rate. Where is that? The average rate of water usage, right over here. And the rate of water usage is going to be qt. So we're just going to put a qt here. And then necessarily we're going to have to change our differential from x to t. And next is going to be over a 24-hour period. Well, it's not really specified what my units of t here are, but we're going to assume that they are going to be units of hours. And then we just need to go from 0 to 24 hours. Now, for me reading this, I would say that we've made quite a few assumptions here, most notably that the unit of t here is a unit of time. So you're going to have to watch out for that as well. Well, this is a calculator. This is a calculator question, so we should get to this on the calculator. So I think the easiest way to do this is on the calculator. We'll go to the y equals menu, clear off our screen, and then drop in our function in y1. We can't use t here, so we have to keep everything in terms of x. I think it's a smart idea to type everything into the y equals menu. Rather than trying to do everything in the home screen, I think it's easier to error check from this screen. Now, from the home screen, we're going to call up our integral. Actually, let's not do the integral just yet. We do need to use 1 over b minus a. And I really don't think there's anything wrong with putting 24 minus 0 here. Now we'll call our integral and go from 0 to 24 of y1 dx. And that should get us an answer. It's 10.58. We'll write that down, and we're not given a unit, but we know that the actually, do we know that this is the qt's in gallons? No, we don't know that qt's in gallons. So there's another assumption. The next assumption we're going to make is that, well, we already calculated with hour, so assuming that the water flow is in gallons, we're going to put this in gallons per hour. And that takes care of our number 1. We'll just leave a couple of calculator screenshots here to help anyone out in the future. And let's look at number 2. The rate at which water flows out of a pipe is given by this differentiable function r of time t, r of t. The table below records the rate at 4-hour intervals in a 24-hour period. Answer 5 through 6 using the information below. Well, 5 through 6, that part here, that shouldn't be here. So the first one is to use the trapezoidal rule with 6 divisions to estimate the total number of water flowing out of the pond. Total amount, so we're just going to integrate gallons per hour, and that'll give us total amount. So if I integrate gallons per hour, that will give me number of gallons. Let's check to make sure that we have 6 subintervals. 0 to 4 is the first one. 4 to 8 is the second one. 8 to 12 is the third one. 12 to 16 is 4. 16 to 20, that's the 5th subinterval. And then 20 to 24, that's going to be the 5th subinterval. I also notice that all of these are in delta. Well, my delta t here is 4 for all of these. So because delta t remains 4 for every interval, we have an opportunity to use the trapezoidal formula. Now I'm going to write down the trapezoidal rule specific for something with 6 intervals. And if we have 6 intervals, that means we have 7 values of f. What might throw you off is that this last one, you might think that's going to be f of x7, but if we call this first one f of x0, then that actually works out. There are 7 values of x here. It just so happens that where the first one is 0 and the last one is 6. Okay, we're doing our function of r in terms of t, so we're going to change everything to r and t. We know that delta t is equal to 4. We also know that a of 0, a is equal to 0, and b is going to equal 24. And now we can start substituting t0, which is actually 0. t1 is 4. And then we'll just keep substituting all the values of t. And yeah, we're ready to hit the calculator at this point. Actually, before we hit the calculator, let's substitute the rates now. Okay, with everything substituted in here on my paper, I'm going to go over to the calculator and start. I'm not going to bother simplifying 4 over 2. I think just typing it in here will save me the trouble of making a mental mistake with my arithmetic. So here we're just typing in the formula. And with everything typed in, we'll go ahead and get an answer of 253.6. Now on my written work here, I did notice something weird. Since we're using a trapezoidal approximation, we really shouldn't be using these equal signs in between. These are approximately equal. So that is going to be the correct thing here. So we're integrating a rate. The rate is gallons per hour. And our unit of time is hour. So this unit should also be gallons. Okay. And that takes care of question 2. Let's look at question 3. We want to use Euler's method to solve the initial value problem. dy dx equals x minus y, with y equals 2 when x equals 2. We'll use increments of delta x equals negative 0.1 to approximate the value of y when x equals 1.7. So in our first increment, we have x equals 2, y equals 2. M is equal to 2 minus 2, which comes from the dy dx equation. So 2 minus 2 is 0. We're told delta x is negative 0.01. Delta y is going to be m times delta y, or m times delta x, which is 0 times negative 0.1, which is 0. Now that I have my delta x, delta y, and delta x, I can get my new x. X is equal to x plus delta x, which is 2 plus negative 0.1, which is 1.9. Y is equal to y plus delta y, which is still 2. This gives me this gives me the coordinate 1.92, and we need to stop when we get to 1.7, so we're ready for increment 2. Again, we're going to calculate the slope. This time the slope is, well, it's still x minus y, but now my x coordinate is 1.9 and my y coordinate is 2, giving me an m of negative 0.01. Delta x is still equal to negative 0.1. Delta y is still m multiplied by delta x. delta y is going to be equal to m, which was negative 0.1, multiplied by delta x, which is negative 0.1, and that gives me a 0.01 for my delta y. My new x is going to be the old x plus delta x, which is 1.9 plus negative 0.1, or 1.8. My new y is y plus the old my new y is the old y plus delta y, which is equal to 2 plus 0.01, which is 2.01. And that gives me the coordinate 1.8 and 2.01. Since I want to estimate 1.7, I'm not quite there yet, so I need to do another increment. We'll do the entire thing all over again, starting with m. That's equal to x minus y. My x coordinate is 1.8. My y coordinate is 2.01. That gives me a slope of negative 0.21. Delta x is still negative 0.1. Delta y is always m multiplied by delta x. In our case, that's going to be m, which is, where's my m? Yeah, my m is 0.21, and my delta x is equal to negative 0.1. This gives me a delta y of 0.021. The new x coordinate is the old delta x coordinate plus delta x. The old x coordinate is 1.8, and the delta x is negative 0.1. That gives me a new x coordinate of 1.7. The new y coordinate is the old y coordinate plus delta y. The old y coordinate was 2.1. The delta y is 0.021. And that gives me the new y coordinate of 2.031. Putting that information together, we get the coordinate 1.7 and 2.031. So now we know that when x equals 1.7, the y coordinate is 2.031. Let's go back up to the top over here, and it says to estimate the value of y when x equals 1.7. So when x equals 1.7, y is approximately 2.031. Now the calculator that you're going to be using for this one is definitely going to be something a little bit, well, more like a four-function calculator. It should be enough to get a lot of this thing done. Right, let's take a look at number 4. We have find the general solution to the exact differential equation dy dx equals 2e to the x secant x tangent x minus root x. Now this is one of those problems where just because you have a calculator doesn't mean you're going to use the calculator on every question on this part of the exam. This one in particular says to find a general solution. So for a general solution, there are no calculations to be made. The only thing that you need to do is find antiderivatives. So if we start with dy dx equals 2e to the x plus secant x tangent x minus root x, we get that dy is equal to the quantity of 2e to the x plus secant x tangent x minus the square root of x dx. We have successfully separated the variables. All the x's are on the right side, all the y's are on the left side. Now we have the integral of the left side is equal to the integral of the right side. The antiderivative of 2e to the x, that's just 2e to the x again. The antiderivative of secant x tangent x, Well, the derivative of secant x is secant x tangent x. So the antiderivative of secant x tangent x is just secant x. And then the antiderivative of x to the 1/2 power, well, 1/2 plus 1 is 3/2. So we get the reciprocal of 3/2, which is 2/3 x to the 3/2 power plus constant. And that takes care of question 4. Question 5, find the solution to this differential equation. dy dt is equal to ky, and k is a constant, and it's going to satisfy these initial conditions where y0 is equal to 100 and k is equal to 1.5. So let's write this down. dy dt is equal to k multiplied by y, and k is 1.5. Now you're supposed to recognize this as the differential equation for exponential growth and decay. So you're supposed to have memorized that if this is the differential equation, then this is the antiderivative. And actually, we know k was 1.5, so we can just substitute a 1.5 in for k. But if you don't remember the differential equation and its solution for growth and decay, then I suppose we should go over the antiderivative here. We'll start off by dy dt equals 1.5y. This means that dy on y is equal to 1.5 dt. This means the antiderivative of dy on y is equal to the antiderivative of 1.5t, which means that the natural log of the absolute value of y is equal to 1.5t plus constant. And I'm going to tell you that y is going to be positive because we're talking about an amount of stuff. Usually we're talking about the amount of radioactive material or the number of organisms and whatever it is we're looking at. So actually we don't need the absolute value of y. And the other way to look at it is over here, y0 is already 100. So we already know that y is going to be a positive quantity. However you want to look at it, we don't need the absolute value for y. The next step in solving here is to exponentiate. So e to the natural log of y is equal to e to the 1.5t plus c. Exponential of the entire left side equals the exponential of the entire right side. Right now you should be wishing that you just memorize the equation, which I would recommend you do, especially for this final. E to the natural log of y is just y. Over here we can use properties of exponents, and we can say that e to the 1.5t plus c is e to the 1.5t multiplied by e to the c. Oh wait, e to the c is just a constant, so we're going to, instead of saying e to the c, we'll replace that with another constant, which we typically call a. And then we'll use multiplicative, commutative power of multiplicity to move the a to the front of the e. Now this is a very specific formula, and we know that a is actually the initial quantity of y, so it's customary to make that y0 in some cases. So we had to go a long way to get to something which you could have just memorized how to do. That's totally up to you how you do your business. Now, the next thing to know is that we have y0 is equal to 100. So we're going to substitute that in here. So my t is going to be 0. And that's going to be equal to 100. Well, e to 1.5 times 0, that's just 0. And e to the 0, that's just 1, which since we're multiplying we don't need. So we actually get that y0 is equal to 100. which means my particular solution is y equals 100e to the 1.5t. Let's see what's next here. We're supposed to find the solution. Yeah, so this is my solution. Y is equal to 100 multiplied by e to the 1.5t. That's my particular solution, the one that we're looking for. Speaking of exponential growth, number 6 is a mold culture doubles its mass every 3 days. This is exponential growth. So we're supposed to find the growth model for a plate seeded with 1.2 grams of mold. As I'm reading this problem, it doesn't really tell me what units to use for t, but since this says 3 days, we're just going to say that t is going to be in units of days. Now it says that the plate is seeded with 1.2 grams of mold, and that says to me that P0 is equal to 1.2. Or if you want, you can even call that Y0 if you want. Now in terms of equations, we have that the population, the amount of mold is going to be equal to 1.2 grams multiplied by e to the kt. Now the next thing is that this mold culture is going to double its mass every 3 days. In other words, when t equals 3, the amount of mold will be double that after 3 days. So that's going to be, it's going to double its amount, and its initial amount was 1.2. So if we double 1.2, we get 2.4. So when t equals 3, p is equal to 2.4. Let's put that into our equation. So we have 1.2 multiplied by e to the 3k. Notice that t is now equal to 3, as indicated over here. And that amount is going to be equal to 2.4. Now we proceed to solve for k. And actually, I'm reminded that you have a really nice calculator in front of you. So we can actually just use the solver mode here. So I'm going to go ahead and clear out. The left side should be equal to p. The right side, let's make that into our model. That is, 1.2 e to the kt. We'll scroll down over here and we'll put things that we know. We know that when we know k, actually no, we don't know k, but we know that when t equals 3 days, p is equal to 2.4. We're going to make sure the cursor is on k, then we'll push alpha enter, and that will give me a value for k that's 0.231. So p of t is equal to 1.2 multiplied by 0.231 t. Just like before, we use the calculator significantly in this, so we'll just put that little bit of calculator notes here. Let's see, number 7. Well, I think this is going to have to be where we stop our video for today. Good luck. We'll have one more video where we finish off this calculator section. We'll see you on that next one.